Hello everybody, my name is Ethan. Welcome back to the channel where today we are going to be covering inheritance in C#. If you haven't watched my previous videos detailing the stuff in C#, we go over a bunch of different concepts. In the last video, we talked about interfaces, which is a part of this chapter, interfaces and inheritance. Please check out that video if you haven't already. If you check out that video, you'll notice I'm wearing the exact same thing I'm wearing today, and that's because I recorded those videos today back to back. So we are doing a little bit of extra work today, but hopefully it pays off. So without further ado, let's go into the introduction to inheritance. Duplicated code leads to errors. Say you have two classes, sedan and truck. They're different types, but they share a few properties like methods, speed up, slow down. If one of those members, say speed up, has to change, then we would have to change the code in every location where speed up is defined. In this case, it's two classes, but in other programs, it may be many, many more. There are two reasons that we don't want to make the same change on code across multiple files. First off, it's a waste of time, and more importantly, it's a big risk for making mistakes. In this lesson, you'll learn a solution to this problem, inheritance. With inheritance, you can define one superclass that contains the shared members like speed up and slow down. All classes that need those members can inherit them from the superclass. So, a little bit of an intro to inheritance here. Check out the sedan.cs and truck.cs. What code is duplicated across these? So, as we can see, we have two different classes here, sedan and truck. So we can see that there are many things that are copied over here. Obviously, we have license plate, speed, wheels. Those are just three in truck. That we can also see license plate, speed, wheels. Three we can also see inside of sedan. So a lot of duplicate information, something that if we want to change it in one place, we can, but then it messes with stuff. So let's learn about inheritance. So first, superclass and subclass. In inheritance, one class inherits the members of another class. The class that inherits is called a subclass or derived class. The other class is called a superclass or a base class. In our car example, sedan and truck are subclasses or derived classes. They will inherit members from a new car class called vehicle, which is the superclass or base class. Before using inheritance, both classes had wheels, license plate, and speed properties, honk, speed up, and slow down methods, and similar constructors. We can pull these out of both classes and put it in a vehicle class. Sedan and truck will still have access to those members, but we only need to write them in just one place. By the way, this inheritance hierarchy can extend either way. A new pickup truck class could inherit from a truck, which inherits from a vehicle, which inherits from a new machine class. The only rule is that a class can only inherit from one base class. Example, vehicle can't inherit from machine and contraption. So we can't have one subclass inheriting from multiple superclasses. It just has to be one down to the next, right? So let's take a look at the diagram representing inheritance. Sedan and truck inherit from vehicle. Members in black font are defined in that class. Members in gray font have been inherited from a superclass. So as you can see in this vehicle, we have both sedan and truck that are both vehicles. But in sedan, we have a new method called just sedan, which is going to be the constructor. But in truck, we also have a new property called weight, as well as the constructor truck. Let's create a superclass. A superclass is defined just like any other class. And a subclass inherits or extends a superclass using that colon syntax that we also used in the interfaces. So when we create an interface, we also inherited stuff from an interface using this colon syntax. We use the same exact syntax when we inherit from a superclass. A class can extend a superclass and implement an interface with the same syntax, separate them with commas, and make sure that the superclass comes before any interfaces. So this means we can inherit from both a superclass and an interface, which is very helpful to know. And if we want to do both, we'll just separate them via a comma. The above code means that a sedan will inherit all the functionality of the vehicle class, and it would promise to implement all the functionality in the automobile interface. In vehicle.cs, build an empty vehicle class. So we've done this before. We're going to just use the class keyword followed by the name of the class, in this case, vehicle. And then we will open that up, and we just want to use an empty one so far, so we will just open it up like that. So next it's going to want us to define some things inside of the class. So for starters, we are going to use the public keyword, of course, followed by string and then license plate, which is going to be a property. So in that property, as it says in the instructions there, it just wants a getter for that one. In the second one, we want a public double speed. Let's use the correct syntax here. Double speed property that has, as it says, a public getter and or not even a public getter, but a private setter, and the other can be staying the same here. And one thing I'm going to do, just so that you guys know what I'm talking about, we'll do a little bit of a comment here. After that, we'll do another. Let's remember our public keyword so we know who can access it within the space here. Just a getter only. And then we're going to go on to our methods. So I'll do another little comment here where I'll say methods. We'll do a void, or sorry, a public void honk method. And in that method, I will just do console.writeLine with just the word honk in it. And then we'll do another public void speed up. And if you don't know what these are doing, then you can watch the previous video that will detail why we're doing the things that we are doing with these methods. So we'll do plus equals 5, and then finally we'll do a public void slow down with a speed minus equals 5. All right, so we have our properties, we have our methods. Perfect. In sedan.cs, use colon syntax to announce that sedan inherits the vehicle class. So we go to sedan. Here we'll also include now vehicle, and I think I spelt that right. So now we just do that. Perfect. Sedan now inherits the members you defined in vehicle. Remove them from sedan.cs. You may still see errors, and that's okay. We'll fix those in the next exercise. So, right, we are gonna able to now get rid of this. We'll obviously keep the constructor here, and we'll get rid of honk, and I guess also these two right here. So now the only thing in sedan is just its constructor. So we do still see errors, but again, it says we'll fix that in the next exercise. Access inherited members with protected. While working on vehicle and sedan, you may have seen this error. Property or indexer vehicle.wheels cannot be assigned to blank blank. It is read only. Remember public and private? A public member can be accessed by any code outside of the enclosing class, and a private member can only be accessed by code within the same class. There is no setter for vehicle.wheels, or so it's saying the above error comes up because either there's no setter for vehicle.wheels or the setter is private. How do we fix this problem? Making the setters public is not secure. Making it private is too restrictive. We only want the subclass sedan to access the property. C# has another access modifier to solve that. Protected. A protected member can be accessed by the current class and any class that inherits it. In this case, if that setter for vehicle.wheels is protected, then any vehicle, truck, and sedan inheritance can call it. In vehicle, add a protected setter for each of these properties. So it's wanting me to add protected. It doesn't really tell me exactly how to do it. I would assume we just add the protected keyword, but I'm not exactly sure how we would do that. And it looks like we just add it in front of it. So we're going to want to add a protected setter to each. So we will do this. I'll replace the private there with protected. And finally, in this case, we'll do protected set. See how that works? Perfect. So now we have a couple of things being printed out. Perfect. Remove duplicate code. At the start of this lesson, we had duplicate code in sedan and truck. We know that duplicated code leads to errors, and so we created a superclass vehicle to contain that code. But one version of the duplicated still lives on in truck. Once we have truck inherit from vehicle, we can remove that code as well. At that point, we'll have 3 classes that have speed, license plate, and slowdown, etc. But we'll have only written it in just one place. So we're going to make truck inherit from vehicle and then use the colon syntax and remove the duplicated properties. So we're in truck.cs now. So we'll have it inherit from vehicle. And then we'll get rid of all of the duplicate code. That is going to include these 3 to start. We know that the weight is not a duplicated code because weight is a property that is only used in truck. So we'll keep that, as well as the constructor here we will keep, but we will get rid of speed up, slow down, and honk. So now that we got rid of all, that, we have everything ready, and now I can click run, and hopefully I didn't mess up a bunch of stuff. And we have done that. Perfect. Access inherited members with base. To construct a sedan, we must first construct an instance of its superclass vehicle. We can refer to a superclass by inside a subclass with the base keyword. For example, in sedan, base.speedup refers to the speedup method in vehicle. There is a special syntax for calling the superclass constructor, which looks something like this. Public sedan double speed base speed. The code above shows a sedan that inherits from vehicle. The sedan constructor calls the vehicle constructor with 1 argument, speed. This works as long as vehicle has a constructor with 1 argument of type double. Even if we don't use base in sedan, we will call vehicle constructor without an explicit call to base. Any subclass constructor will implicitly call the default parameterless constructor for its superclass. For example, this code will implicitly call vehicle. So we have class sedan inheriting from vehicle, and if we just did public sedan double speed, it will implicitly call base, aka vehicle. The above code is equivalent to basically that. The code only works if the constructor vehicle exists. If it doesn't, there will be an error thrown. Currently, the sedan constructor implicitly calls the vehicle default parameterless constructor, also known as vehicle. Let's explicitly define a constructor in vehicle. It should look similar to the sedan constructor with a few differences. So we're inside of vehicle. We're going to create the constructor here. I'm going to put it below right here. So constructor, and we will do public vehicle. It's going to say it's 1 parameter, that being double speed. And then if we open this up within the constructor, it sets speed equal to speed, and then license plate. After doing this, you may see the error below. So I'm going to assume that we're going to be using the same code that we did before, which was tools.set license plate. I believe that's what we're going to be doing. Okay, we got our blue check mark here. We can now go down and go back to sedan.cs, delete the lines in constructor that set speed and license plate. So if we go into the constructor, now we can get rid of, it's generate license plate. So let's, instead of set there, we'll use generate license plate. That's probably, no set license plate right there. So we'll get rid of the speed part of the constructor, and we'll get rid of the license plate part of the constructor within sedans. In the constructor, call base with this. Sorry. We're going to want to do, we're actually going to want to call it. So if we do sedan double, back in sedan.cs, delete the lines in the constructor, and then call the superclass constructor. So actually, I believe we'll want to do that outside of our own constructor. So we'll do one that looks something like sedan double speed is equal to, or not equal to, but base speed. Believe that works now. So yep, we got the blue check mark, which is perfect. We also have a couple of errors here, but that's fine. Let's repeat the process in truck.cs. So if we go back into truck.cs, we will get rid of the speed and license plate parts of the constructor, and instead, after this constructor here, we will call truck double speed double weight, and we'll do that base speed. Alright, since the license plate speed properties defined in vehicle are no longer accessed in sedan or truck, they no longer need to be protected. Switch those two getters or setters to private. So now if we go back into here, we can now, because they are not actually even being accessed anymore, we can just set it back to private, and nice. So still getting a couple errors here, but that's fine. We are finished with that. Override inherited members. Say we wanted to make one more vehicle that operates a bit differently than a sedan or truck. We want to use most of the members in vehicles, but we need to write new versions of speed up and slow down. What we want to do is override an inherited method. To do that, we use the override and virtual modifiers. What we want to do is override an inherited method. To do that, we'll use the override and virtual modifiers. In the superclass, we mark the method in question as virtual, which tells the computer this member might be overridden in subclasses. In the subclass, we mark the method as override, which tells the computer, I know this member is defined in superclass, but I'd like to override it with this method. As an aside, there's another way to solve this problem. Instead of using virtual and override to override a member, we can define a new member with the same name. Essentially, the inherited member still exists, but is a hidden by the member in the subclass. If this sounds confusing, that's okay. We also think it leads to unnecessary confusion, and that leads to errors. We're going to stick with the virtual override approach in this lesson. So our new class, bicycle, will access the wheels and speed property in vehicle. So make sure both setters protected again in vehicles.cs. So we'll go back here and set speed back to protected. Cool. All right. Wheels should already be protected. We set that a few exercises ago. That is exactly what we saw. In bicycle, let's create an empty class that inherits vehicle. So we'll use the class keyword called bicycle, and it will inherit from vehicle. And we'll open that up, and for right now, it's going to be empty, which is perfectly fine. Let's now define a constructor within the bicycle class that has one double parameter setting the speed property, calls base with that parameter, and in its body sets wheels to 2. So let's do that. We'll first do a public bicycle that has one double parameter called speed that it inherits from base speed, and then inside of the constructor we will set wheels equal to 2. And hopefully I did that right. Public define a okay, so it didn't want me to actually do it like that, and I think that's fine if I do that instead, maybe. Bicycle constructor should call base speed. So let's take a hint here. It wants us to do something like that, which is pretty interesting. So we do public. Well, we would do public bicycle with double speed, and then do the constructor at the top where we do base speed. And hopefully that works. Base constructor. Okay, that ended up working out. Now let's define a public void speedup method that limits the speed to 15. In other words, the method to body add 5 to speed. If speed is greater than 15, set it equal to 15. An error might occur here, which is okay. So we want to, within the class here, we want to create a new method. So we'll call a public method that is void, and it will be called speed up. And inside the method, it will do speed plus equals 5. And then we'll do a check if speed is greater than 15. If speed is greater than 15, we will open that up now. And if it's greater than 15, we'll set speed equal to 15. You probably saw the warning, bicycle.speedup hides inherited member. So in line 9, it's saying that it can't be public. Let's view the solution and see if there's something different here. Public.speed. I don't think we've gotten to this point yet. But it doesn't want me to actually do it within. It just wants me to instead do something like this. The computer section, new approach where we prefer in bicycle label speed up with override. So we'll do public override $R. And let's see if that fixes some of the errors on the right-hand side in the console here. Hopefully it does. Now you probably saw the error. Cannot override inherited member vehicle speed up because it does not mark virtual, abstract, or override. In vehicle.cs, label speed up with virtual. So if we go here, we'll go to speed up, and now we'll label it with virtual. Repeat the process with slowdown in bicycle.cs. Let's assume that only sedans and trucks can go in reverse. It should override the inherited version and limit the speed to 0. In other words, the method subtracts 5 from speed, sets to 0 if speed is less than 0. It labels override. So we're doing the exact same thing. We're creating another new method within this where it is a public override void method called slow down. Inside the method, speed minus equals 5. If speed is less than 0, speed is equal to 0. And it's going to give us that same error where we cannot override expected. Oh, I think I messed up some of the things here. Yep, I did. And then, yep, so now we can't override because it's not marked virtual. So let's head over here and do the exact same thing for slow down. If we do the virtual keyword, now we should be good. Perfect. Make inherited members abstract. Now we want to add one more method to vehicle called describe. It can be very different for every subclass, so there's no point in defining a default one in vehicle. Regardless, we want to make sure that it is implemented in each subclass. This might sound similar to an interface. Why not add this method to iAutomobile interface? We want describe to be available to all vehicles, not just automobiles. To do this, we need one more modifier, abstract. This line would go into the vehicle class. So we would create a new modifier using the abstract keyword. This is like the vehicle class telling its subclasses, if you inherit from me, you must define a describe method because I won't be giving you any default functionality to inherit. In other words, abstract members have no implementation into the subclass, or in the superclass, but they must be implemented in all subclasses. If one member of a class is abstract, then the class itself can't really exist in an instance. Imagine calling vehicle.describe. It doesn't make any sense because it doesn't exist. This means that the entire vehicle class must be abstract. Label it with abstract as well. So we would do abstract class vehicle. If you don't do this, you'll get a message like vehicle.describe is abstract but contained in a not abstract class vehicle. Once we write the abstract method and mark the class as abstract, we'll actually implement it in each subclass, for example, sedan. So we have something like that. To make it very clear that this describe method is sedan is overriding the describe method in vehicle, we need to label it override. All right, we are going to add the abstract method into vehicle.cs, and we will label it public abstract void describe, and it actually might be a string that we want to return. Yeah, it's actually a string that we want to return, so it's not actually that, and it's a method, so we'll put in the parentheses there. Describe should be public and return a string. Vehicle should also be labeled abstract. So now when we go here, we'll have to label this as abstract. You might see an error after this. Perfect. If we just do this, hopefully we see, actually ended up add the abstract method describe to the vehicle class. Because I didn't actually add anything into the thing, which is fine. I think that works instead. This just tells it that it needs something, right? Yeah, okay, cool. You probably saw this error. Bicycle does not implement inherited abstract member vehicle.describe. Exactly. So because of that, we can fix this by implementing describe methods in bicycle, sedan, and truck. Each method should mention the type. Example, the bicycle version of the method returns a string containing bicycle. Mention the license plate, speed, and wheels. Be labeled with override for bicycles. The return string might look like this. So if we go into bicycle, we'll now create the method of describe. So we'll do a public override string method called describe, and in this method it should console.writeLine, and we'll start a little bit of string interpolation, and we'll say this bicycle is moving on wheels at, or not capital, wheels at speed kilometers per hour with license plate. And boom. Let's see how this works. Okay, so we have to do the exact same thing inside of, and I did not put a, I was doing good there for a second. That was almost 3 videos in a row where I didn't forget a semicolon, but as you know, I suck. So let's now do the exact same thing in sedan, where we do public override string method called describe. In describe, it should have no parameters and should console.writeLine print out something that uses string interpolation. We'll say this sedan is moving on wheels at speed kilometers per hour with license plate and I'm going to do the exact same thing but for truck. We'll add this off to the end. Ooh. we'll do a public override string describe, and open that up and do console dot writeline, and this truck is moving on wheels. Let's feed it with license plate. Okay, now I've done it for all three. Gives me a nice blue check there. And of course, I'm playing like a newbie here and not actually doing my semicolons as you would. It's going to give me a red X because I didn't call it yet. But let's go to program.cs now, and we'll do call describe on each instance and print the result to the console. So we'll do a console.writeline, and we'll do s.describe with the function here, and we'll copy and paste this, and instead of S we'll do T for truck, and instead of S we'll do B for bicycle. So now when we console.writeline s.describe these out, we get a blue check mark, but something isn't right. So is that what they wanted me to do in program.cs? They did it kind of a little differently there, but that shouldn't matter. Okay. Not all code returns a value. So actually, when I did this, I should have, instead of doing console.writeline, it should just be the return statement, since I have that. So we'll do that quick, and that should end up working nicely for us. Return. And hopefully that works out for us now instead. Perfect. Now we actually get the stuff that comes out here. So the sedan is moving on 4 wheels, 12 wheels, 2 wheels. Perfect. Ended up working out. All right, let's do a little review here. Well done. You've learned a lot very quickly. So let's do a review. Inheritance is a way to avoid duplication across multiple classes. In inheritance, one class inherits from members of another class. The class that inherits is called a subclass or derived class. The other class is called a superclass or base class. We can access the superclass's member using base. This is very useful when calling the superclass's constructor. We can use restrict access to superclasses using protected, and we can override a superclass using virtual and override. We can make a member in a class without defining its implementation using abstract. Okay, I believe we have a quiz first, and then I believe maybe 2 projects here. That's typically how we've been doing it. Let's first pick the true statement. A superclass inherits from a subclass, don't like that. A base class inherits from a derived class, don't like that. A base class inherits from a superclass, don't like that. A derived class inherits from a base class, I do like that one. What does it mean for a class member to be abstract? So that means A, the member cannot be accessed by any class. The member has a missing or incomplete implementation. It must be implemented from derived classes. I like that one the most, and that is correct. What is inheritance? Is it a type of class, a process of writing duplicate codes in multiple classes, a process by which one class inherits the members of another class, a definition for a group-related functionalities that class can implement? I like this one right here, the process by which a class inherits, and that is correct. Fill in the code so that the worker B class inherits from the B class. So we have a worker B class, and it should inherit using that colon syntax from the B class. Perfect. Fill in the code so that the calculator extends the computer class and implements the clickable interface. So we want a extends the computer class and implements so that the calculator extends the so class computer. Fill in the codes of the this vocabulary word of extends is interesting. If I had to guess, it's going to be something like this. Sorry, no, it would be something like this, but I don't know if it's this here and this here. So that calculator extends the computer class I'm going to do this. And that is right. Perfect. Fill in the code so that the Gigantosaurus.warn overrides the Dinosaur.warn method. So we have to have a couple of things. The first thing would be that we would override down here, meaning we would need it to be virtual up here. Why will this code cause an error? Interface iPersonable, date time, birth time, class passport from impersonable. Okay. Let's check. iPersonable is not a legal interface name. Sure it is. Interfaces cannot contain properties. That's not true. The passport class does not correctly implement the interface. Or the interface is missing member implementations. I like this one the most. Yeah, passport needs to implement the two properties. So you can see here there's nothing implemented yet. So if you run this code, you're going to get that error. This code will throw errors. What changes will fix those errors? So we have a class called building that has two private variables. One is a int variable named x. Second is an int variable named y. We have class garage that inherits from building, and we're going to try and pull x, but what can we do? We would have to change both private fields to protected. Private members cannot be accessed by derived classes, but protected members can be. Given that iMachine is an interface, what does the first line mean? The tractor class implements the iMachine interface. The iMachine interface implements the tractor class. There's one class named tractor. Calling class, yeah, no, it's the first one there, right? Fill in the code so that the worker B implements the iFlyable. So worker B implements iFlyable. And we did perfect on that interfaces and inheritance quiz. So I believe now we have a couple of projects here, possibly two. Looks like two. App interfaces. The team at Computertron Computing has asked you to join the product team to develop the hottest new Computertron computer. You'll be responsible for building some of the standard apps on the new machine, specifically the to-do list and password manager. At this point in development, you have two classes started: to-do list representing the to-do list application and password manager representing the password manager. In order to work with the Computertron system, every app must have a display and reset feature. In other words, each class will need to implement the iDisplayable and iResetable interfaces. Classes can implement multiple interfaces using the colon and comment syntax. Let's get started. Get comfortable with the two classes. You can see in program.cs an instance of each class is constructed. So in main, we have to-do list. Then we'll have to-do list, invite friends, add, password manager is just created. In password manager, read the definition of the constructor. So the constructor says it takes two variables. It sets password equal to password, hidden equal to hidden. Every app must have a display feature, define an empty iDisplayable interface. So we need a new iDisplayable interface. Using the interface keyword, we will call it iDisplayable. Open that up really quick. One method. We did the number 2, so let's go on to number 3. Within the iDisplayable, we'll declare one method that is named display. So we'll do public void display. In to-do.list, declare that the class implements the iDisplayable interface. So if we go to to-do-list.cs, we'll say that inherits from the iDisplayable. Let's save this. The class must actually implement the interface by defining a display method. Define a method that satisfies the interface requirements. Uses console.writeLine to write each to-do item. Okay. So declare one method. So we just We didn't actually want to open up here. We don't call it public within an interface. We would just call it void display. So let's save that. Go back to to-do list. The class must actually implement the interface by defining a display method. Define a method. So let's go down here and define a public void method called display. Takes no arguments. Satisfies the interface requirements. And write each to-do item in the console. For each string to do in to-dos, console.writeLine to do. Repeat the process for password manager. Declare that it implements iDisplay. So we go into password manager. We'll say that it inherits from iDisplayable. And we're repeating this process of defining the method of display by doing public void display. That will what? Define a display. Oh, define a display method that satisfies the interface requirements. When it says that, by satisfy, we mean that the to-do list must have a display method with the same signature as display and iDisplay. Depends on the value of hidden. Uses console.writeLine to print the actual password. If hidden is false, if hidden is true, prints asterisks. So if hidden is false, prints password. Else, I get rid of that one. Else, open that up and say prints asterisks. So we'll do console.writeLine and we'll do password.blank times hopefully that works. All right, so we have saved this now. In this, we will do tld.display and pm.display. And then in the top right, we'll do .NET run. And if I had to guess, I've made an error somewhere. So, didn't like this syntax. That's fine. I'm just going to do that amount of asterisks instead of doing anything else. And then we'll do a good old .NET run. Oh, come on, .NET run. Okay, well, it actually looks like I did it correctly. It ended up printing out invite friends, by decorations party, and then the 6 asterisks that I wanted it to do. So we did actually see both things. So I actually didn't make any mistakes. It was just that console.writeLine and the display for the password manager. But other than that, that wasn't a mistake with anything that we've learned. It was just a mistake on what can be done in console.writeLine. Okay, so let's go on and move on. I'm going to actually just quickly reload the page here so that we can get rid of that stuff in the console so you'll be able to see it. Let's go on and move on to iResettable. Every app must have a reset feature in iResettable.cs. Let's go in here. Let's create a iResettable interface. So we'll do the keyword interface with iResettable. And it should just have one method here called reset. And so we'll do void reset, and it should return nothing. So, perfect. Now let's go back to to-do list.cs, and we will make sure that it also implements iResettable. So iResettable, and inside of this, we're going to want to create another public void reset, and it should set password to an empty string and set hidden to false. So in reset, we want to say set password to an empty string. What might be an answer to dot reset? Okay, that doesn't really help me there. Recall the syntax for declaring a new empty array. In this case, numbers is an array of ints with length 10. So we want to do something like this. Implement it and then satisfy the intervals. It should set to-do's property to an empty array of length 5 and set net open index to 0. So in reset, it should do to-do, yeah, okay, so we'll do to-do's equals new string 5. And then it wants me to set next open index equal to 0. Perfect. That's number 10 done. Number 11, now we're going to go to the password manager, and we're going to do the exact same thing. We're going to also inherit from iResettable, and we'll do a public void reset. And in this method, we will want it to declare first that it represents, and then it should set password to an empty string. In this case, how do we set to an empty string? Well, we have an empty array there, so how do you set it to an empty string? The one is easy. The one setting hidden equal to false makes sense, but it wants me to set password equal to just an empty string, perchance. That might work. So now in program.cs, let us call reset and display with TDL and PM. In other words, both objects should display, then reset, then display again. So we have display, and then we'll do TDL.reset, and then TDL.display. And then we'll do the same thing with PM, PM.reset, and then PM.display. Cool, let's run .net run with that. Hopefully we made no errors, but I'm not holding my breath here. Yep, so we reset it so they're both just empty strings, and that's actually what we end up seeing. We don't get anything that's displayed to the console. Perfect. Well done. We can do some extensions if you'd like. If you'd like to pause the video and do some extensions yourself, go for it. But I'm going to continue here with the next project. So the first one is done. Not too challenging there, just some other stuff. But now we are going to do some supernatural inheritance. At the Code Academy Guild of the Supernatural, there are 3 ranks of magicians. They rank from least to most powerful: pupils, mages, and archmages. Or archmages. In this project, you'll be developing a system into C# to track the weather magicians in the guild and their spells. Pupils have a title and can create weak windstorm. Mages have a title and create weak windstorm and weak rainstorm. Archmages have a title and create weak windstorm, a strong rainstorm, and a strong lightning storm. Notice anything shared in these ranks? If we create a class for each type of magician, we would have a lot of duplicated code. For example, every magician has a title and windstorm. To avoid duplication, we'll use inheritance. Pupil will say is the base class. Mage inherits from pupil, and archmage inherits from mage. We'll also need a storm class, which stores the essence, strength, and title of the magician who created it. Let's get started. So we'll start by defining the storm class. In storm.cs, let's create the new class. Let's create an empty class called storm. There's the empty class. Let's define 3 automatic properties. So I'll do here properties. In the properties, we should have each one have a public getter and a private setter. Essence, the storm, a type of storm like wind or rain. Okay, so we'll do that by doing public string essence with a getter and private setter. A public bool is strong, and again we'll just do a public getter and a private setter. Finally, public string caster with that same stuff going on. Okay, so now I assume within the storm class we'll create a constructor that takes 3 arguments, 1 for each property, and the body of the constructor use those arguments to set the property values. So we will go here, and I'm going to do keep the kind of theme of doing some helpful notes. So in the constructors, I'll do one that is called public storm with a string for essence, a bool for is strong, and a string for caster. And inside this constructor, we want to use the arguments to set the property values. So we'll say essence is equal to essence. I assume that's what we're going to do here if I had to get, yeah, exactly, if I had to guess. Just don't want to get us down a long path and it be wrong. Is strong. I'll actually just do just the lowercase one there. Then finally, we'll have caster is equal to caster. Very nice. We have completed the constructor. Uh-oh. Sorry. We'll do is strong. I capitalized it here, but is strong, caster, and caster. Now that we should be fine. A little bit of a mistake there from me, but now we should be fine. We'll need some way to print storm object to the console, define a public announce method. So let's now go down from here and do a new section called methods. And under methods, I will define a new method called announce that returns a string. So we'll do public string announce. And here we want to use all three properties. For example, if a weak windstorm is cast by, the string would be. So we'll say, we'll do a return statement with string interpolation, and we will do caster. Caster. Cast a all three properties. Is strong. Is strong is just going to be a bool. Let me see what it wants me to do here. So, yeah, that's what I thought. So we'll do that really quickly. So in announce, we'll say if is strong equals true. We'll set the value of, we'll create a new variable here, a string variable called power. And we'll say power is equal to the string weak, or I guess if it's true, then it would be strong, else power is equal to weak. So now we'll return caster cast a power, and then essence. So essence was type of storm. So then essence storm. Okay, let's test your class in program dot. Oh no, and I just closed that. So we want to reopen. Which one did I close? I closed storm.cs. Yeah, there we go. And I can't move it, which is fine, but then we just have it still. So in here, we want to test our program, construct a new storm. It should have wind essence. Okay, so let's construct a new storm. So we're going to use the storm object called s is equal to new storm with the variables of wind, not be strong, so false, and then by Zul Rajas. Perfect. After constructing a new element, announce it. So we'll do s.announce. Something was expected in storm.cs. Down here, wouldn't be a video if I didn't mess that up a couple times. Okay, so we have a bunch of errors here, and that's perfectly fine. The name is strong, does not exist in the current context in storm.cs line 28. So it actually should be is strong, is that, so power, or sorry, that should be the only change that I have to make there. Error, the name caster does not exist in the current thing. So yep, that is true. It's actually all the capital ones. So let's just fix that right away. And perfect. So I did string.announce, and I'm saving it. And print the result to the console. So we'll have to do, yeah, my bad. We'll have to wrap this in a console.writeLine as we're not doing the other way right now. So we'll wrap it in a console.writeLine, and that should work now. Cast a weak windstorm. Perfect. Next, we'll define the pupil class. In pupil.cs, define a class named pupil with 2 members. So we'll create a new class called pupil. 2 members, a string title with a public and private setter. This represents the number, the name of the pupil. So we'll do public string title with a public getter, private setter. This represents the name of the constructor with 1 argument. So next it wants me to create a constructor. So first it says I will set this as a property, and then constructors. So just keeping our stuff all together. I did it for the storm one, so I am going to also do it for the pupil one, just so we can keep following along here. And I will add some spaces off the end here so we can separate it just a little bit here. So let's create the new constructor. In constructor, a single argument sets the title property. So we'll do string title. And inside we'll say title is equal to title. And that is that. Give the pupil its single spell, a cast windstorm method. So again, we are going to create a new area called methods. Inside of methods, it wants me to create a new spell. It should return type storm. So again, we'll do public type storm and cast wind storm. In the body, return a new storm object. Construct a new storm object and return. Remember that this is a weak storm cast by the pupil. So it wants to be a weak wind storm. So the first thing that we want to do is create a new storm object. So we'll return a storm object called pupil cast, and we'll say that it is a new storm object with the values of wind, and then the value of false because it's not very strong, and then finally the value of title because that is the name of the person doing it. Give the pupil a single, and remember that it's a weak windstorm created. Test it. So now that should be good. In program.cs, it wants me to construct a new pupil named Mezilcree. So now we'll do okay. So we'll create a new storm is a class. So we're creating a new pupil class, and we'll store it. So we'll say pupil. And we'll say that is Mezilcree is equal to new pupil with the values of, well, pupil takes just the title. So we'll just put the title of him being Mezilcree. I don't know if it wanted me to capitalize that. So, and then after that, it wants me to cast the object of Mezilcree dot cast wind storm. Hopefully that works. And of course, in pupil.cs, I missed something. Where am I missing it? line 21, it says I'm missing a thing here, but where is it that I'm missing it? Huh. Public storm, cast wind storm, and then it should be wind, false, and title, which is what I did. And it has the I'm not understanding what it's saying, because let me reload the page really quickly, because I have the semicolon there. I thought that maybe I didn't there for a second, but I actually do have the semicolon there. It's just that it's not actually seeing it for some reason. Yeah, it's being a little strange here. It doesn't have that. Pupils.cs error expected on line 21. Am I missing something here? I feel like I might be missing something here, because I definitely feel like I have the semicolon there. I have created the new storm object. Variable store the result of cast windstorm in a variable output of the console should look similar to this. Yeah, so when I do it though, it's giving me this error, which I'm not 100% interested in here. So let's recreate the new cast windstorm method. Let's just retype it, and maybe that will help. So let me save quick. Yep, that's perfectly fine. We'll now do a new public. Oh, sorry, it should be type storm, cast wind storm, and it should return a storm object called pupil. I'm going to call it pupil cast, equal to a new storm object of, as it said before, it wants to be a wind, false, and then it would be just title, and we'll put that. Yeah, it's giving me a weird bug here, where it's saying that I'm not putting the semicolon, even though I very much am putting the semicolon. If I look at Get Unstuck, there is a project walkthrough that I will try and visit here. Let's actually just blow it up. This nice person, Carlos, has so graciously give cast windstorm. Right, so that's exactly what we see here. And he has the semicolon just like me. And yeah, so now I'm really confused. And yeah, I guess it's a little bit different syntax than me. So maybe we do return new storm and see if that works instead, but that's very strange. I don't know why it's saying semicolon expected. I'm just going to keep moving on here and not worry about it too much, and we'll move on to the mage class instead. So the next rank mage also has a title property and cast windstorm property. It also has a cast rainstorm method. Instead of writing the first two members again, we can inherit them from pupil. So let's create an empty class called mage, and mage will inherit from pupil. Inside, we will add a mage constructor. So I will continue with the kind of little documentation that I have been doing. So we'll do public pupil, or sorry, mage, and it should have just one string argument. Add a main with one string argument. This should call the base constructor string title, and we can just do now base with title. And give that mage a new cast rainstorm. So that's what I did, and it just doesn't have anything in it, so methods, we want to give it a new spell, so we'll do public a new storm object called cast rainstorm. And in this, it should take a couple arguments, right? It should return type storm in the body. So we'll return a new storm object that should be a rain, false, and title. And that should be good. Let's test our class now by going into program.cs and create a new object called a new mage object called golden equal to new mage called Dan. And afterwards, we'll do mage.cast rainstorm. This is required for the non-static field or method property cast rainstorm. An object reference is required for the non-static field method or property mage.cast rainstorm. After constructing a new object, call cat and store the results in a variable. Use announce to check if that is weak to rainstorm. So we'll say that it returns a storm object, though. Let's see what it says to here. That should be similar to this. You need to call a storm constructor and then bring in all false title, transfer class, income, golden. After constructing a new object called archmage. Okay. In program.cs line 16, so it's saying this is the issue because an object reference is required for the non-static field, and that's because in cast rainstorm, go to mage cast rainstorm, it doesn't have anything there, it just returns the object, but let's check with the video one more time here. Hopefully it's the last time that I have to check the video here. But so he's testing out his thing here. And next rank mage. So we're going into mage. He classifies it as this, public mage. Then it has string title, base. Oh, did I say it was base? I'm wondering if I actually said it was base. No, I did. Okay, so I did do that correctly. After that, though, it just has the empty, which I had, and it wants me to create the cast rainstorm, return rainstorm, and then we did that correctly. In this, it wants us to create a new mage object called golden storm rainstorm is equal to m.cast rainstorm console.writeLine rainstorm dot announce. Okay. So he created a new storm object called, oh wow, we're getting to some interesting places here. So he, instead of just doing this, he set it equal to a storm object called rainstorm, and then did rainstorm.announce, and then wrap that in a console.writeLine. Is that all I had to do? See, yeah, so what is happening here? Oh my goodness, we are going everywhere today. Everyone's going to see what the plans are for the future of this channel. Cast rainstorm.announce, and yeah, it just works perfect for him. So let's see, mage m equals new mage, Gul'dan, rainstorm, and cast rainstorm, and console.writeLine is equal to rainstorm.announce. So let's take a peek again at what we did. Is it similar? Is it different? Mage equals new mage, mage.cast rains. Oh, that's why. So figured it out. Gul'dan.cast rainstorm. We can't cast from that, so this should work now, and we should be good to go. All right, Gul'dan cast a rainstorm. All right, last one, Archmage. In the next rank, Archmage also has a title property and cast windstorm method. On top of that, it overrides cast rainstorm and has a cast lightning storm method instead of writing the two members again. We can inherit them from mage. In Archmage, define an empty Archmage class that inherits from mage. So we will do that quite quickly here. Oh my gosh, we are getting hard on time here. This last one has taken a lot longer, and there's still 7 steps to go. So we'll do that by defining Archmage, and that's going to inherit from mage. In this class, we want to add a constructor where we'll do public Archmage that will take a string title from call base constructor base with the same argument. And then after that, it should override the cast rainstorm spell, just like the one in mage. It should be public with a return type storm. In the body of the method, construct a new storm object and return it. This time, the strong rainstorm is cast by an Archmage. You may see an error. We'll fix it the next step. So we want to do methods. Methods section. In the methods section, we're going to create a new public method that returns a storm object called cast rainstorm. In this, it will return a new storm object with a rain true and title like so. Okay. We want to now fix this. So in storm, we'll do override storm, and then in mage, we should mark it virtual. So in mage, rainstorm should be called virtual. And we did that now. 17, add one more spell in Archmage called public return type storm, and it should be cast lightning storm. Oops. It should return type new storm object that has the values of lightning and then true and then title. And now we can test our class. Perfect. By to test it, all we'll have to do is create a new one, Neelis Aran. So we'll create a new Archmage thing, class called, I'm going to just call it NA1 is equal to new Archmage. nihilus Aran or Aran, and then we'll call cast rainstorm on a new object. Call cast rainstorm object. Rainstorm1 is equal to na1 dot cast rainstorm, and then we'll create an induced object that's a light storm 1 is equal to na1 dot cast lightning storm. And then we'll store it in that object, and then we'll do a couple of console.write lines where we will console.write line rainstorm1.announce and console.write line lightstorm1.announce. See if that works. Perfect. Created a strong rainstorm, strong lightning storm. Perfect. And obviously there are always extensions, so if you want to do that, go for it. But that is going to conclude the video for today. 2 projects done, a quiz, and we finished up an entire chapter. Always one of the more longer videos. In the following video, we'll be talking about references, a completely new chapter within our learning. Just 2 chapters to go at this point. So we are getting to the end here. Obviously, we'll have another project at the end here, but we'll have references next. So thank you very much for watching. If you did enjoy, please be sure to leave a like, subscribe, and leave a comment down below, especially if you knew why I was getting that semicolon at the end there. I don't know why, so if you know why, please leave a comment down below. But I'll see you in the next one. Peace out.